Yeah, welcome back to this YouTube channel. The previous video, we tried to look at the introduction to organic chemistry, where we talked about the different formulas, because these formulas would be used to represent each of the homologous series that we are going to be looking at. Okay, so we'll just dive in straight to what we're supposed to do in this particular video. We're going to look at how we can represent each of these formulas, picking one of the homologous series, which is the alkanes. So I'm simply going to begin with the alkanes. We'll start with the alkanes. And remember that the general formula of the alkanes is CnH2n H2n plus 2. All right, this is the general formula. So this is the formula that we would use to generate every member of this series or of this family. And then when we generate the members, we'll try and get the empirical formula, get the molecular formula, get the structural formula, and also draw the display formula. So let's begin. So the first member starts from n equals to 1. So we begin with n equals to 1. So when we begin with n equals to 1, so wherever we see n, we simply use 1. So we're going to have C1, H2, and since we have a n here, so it becomes 1 plus 2. All right, so from here, we could continue to say that C1, this is 2 times 1, that's 2 plus 2. And that is equivalent to C1, that's saying C multiplied by 1, that's still C, and then H2 plus 2, that's 4. So this is the first member of this series, and it's called methane, right? It has to have the ANE ending, okay? That makes it an alkane group. So it's called methane. So the next thing we're going to do is try and get the empirical formula, try and get the molecular formula, the display formula, and of course the structural formula as well. So let's go into that quickly. So if this is CH4, so remember what we said about empirical formulas. The empirical formulas are the simplest whole number ratio of the atom. So can there be any other simpler form of this? So the simpler form of this is simply the same CH4, because there's no other way we could simplify this, because there is no number we could use to divide all through. So the simplest form of the CH4, so the empirical formula of methane is simply the empirical formula is still CH4, because that's the simplest we can have for this particular compound. All right. And then when we look at the molecular formula stays the same as well, because it's the actual number of atoms there is still CH4. Okay, so its actual number of carbon is 1 and actual number of hydrogen is 4. So that settles it for the molecular formula. Then for the displayed formula, remember what we said, displayed formula shows the spatial arrangement of each member, okay, of each atom involved. So we want to draw carbon. Remember it has a valency of 4. So display formula is going to show the bonds, how they're attached. So 4 hydrogens are attached to 1 carbon. So this is 1, 2, 3, and this is 4. So this is what a display formula looks like. So this is a display formula of methane. This is the display formula of methane. And you can see it's showing the spatial arrangement of all of the atoms involved. And that is how a display formula should look like. All right, and then finally, we're going to look at the structural formula. So structural formula is still going to be CH4 in this case, because there's no other atom linked up. There's no other carbon linked up to the whole thing. So it's still going to be CH4 for the structural formula. All right, so I'll just go and look at a member that is we're going to be able to clearly see how to make use of all of this formula. So I'll go to the fifth member, or you simply use the fourth member. Let's use the fourth member. So let's say n equals to 4. Remember the formula, the general formula is still CnH2n plus 2. So when we got n equals to 4, so we're going to have something like C4 H2 into bracket 4 plus 2. All right, so the formula is going to be C4H, that's 8 plus 2. So we'll have C4H10. All right, so C4H10 is this formula, and this is the fourth member of the alkane, and we call this butane. Butane. Okay, butane. All right, so butane is the fourth member of the alkane series. Now, let's begin. We're looking at the empirical formula. What will be the empirical formula now? So the empirical formula of this compound, remember what we said, it has to be the simplest of this. So think of a number that could simplify this atom. So we could divide by 2. So we divide both of them by 2. So it's basically saying C4 divided by 2, H10 divided by 2. So we're going to have something like C2H5. Okay, so we can't see any other number that can divide this, okay, to give us a whole number, basically. Remember, it has to be a whole number. So we can't see any other number that can divide it. So we simply say this is the simplest. This is the empirical formula of butane. All right, remember what we said. The empirical formula is the simplest whole number ratios of the atoms in the molecule of the compound. All right, now let's go to the molecular formula. So for the molecular, it tells you the actual. So the actual number of atoms involved is simply C4H10. So this is the molecular formula of butane. Or you can see that in this case, the molecular formula is different from the empirical, unlike the previous question we solved for the alkanes. All right, now let's go to the next one, which is displayed. All right, so I'm going to need a bit of space for displayed, so I'm just going to draw. So for the displayed formula this time, displayed. So displayed is going to be equivalent to, so 4 carbon atoms, 1, 2, 3, 4. And remember that the valency of carbon is 4. So it can only have 4 atoms attached to it. Okay, so I'm expected to attach 10 hydrogens to all of these 4 carbon atoms. So this one is expected. This is H, H, and H. Now, this is 1, 2, 3, and this is the fourth bond. So I can move to the next carbon now because the valency of carbon is 4, and it should only have 4 bonds attached to it. So this is the first one. This is 1, this is 2, this is 3, and this is the fourth bond attached. So we cannot attach any other thing to this carbon because we have maximized the valency. So move to the next carbon. So we attach just 2 hydrogens to this because we're going to show why that's possible. Because this bond here is 1. So this is 1, this is 2, this is 3, and this is the fourth one. Okay, and then we go ahead to do the same thing to the next carbon, just 2 hydrogens. And then for the last carbon, we're going to have 3 hydrogens so that you can complete 4. Okay, so we could complete the 4 number of atoms attached. So this is displayed. You can see what displayed is showing. It's showing how the spatial arrangement of all of the atoms, how all of the atoms are linked up. And that is the major point you need to note when you're drawing display. Now, we need the display to get the structural. So that's why I'm picking this question. So I'm going to get the structural now. So the structural formula is going to be something like this. So we're going to draw the displayed first, and then you use the display to get the structural. All right, so let's get the structural. So we pick the first carbon. Yeah, how many hydrogens attached? 3 hydrogens. So it becomes CH3. All right, and then what do we have? We have a bond. And then you pick the second carbon. How many carbons? Just 1 carbon with 2 hydrogens. So CH2. Then there's a single bond again. And then you have the next one. This is a carbon with 2 hydrogens again, so CH2. And then you pick the last carbon with 3 hydrogens, so CH3. So this is what a structural formula is supposed to look like. You can see that the structural formula is different from the displayed formula in terms of representation. All right, some other way you could simply just write it as CH3, CH2, CH2, CH3. So this is what a structural formula looks like. So you can practice with different members of the alkanes. We have the first member, okay, which is methane. We've done methane. You could have ethane, propane, butane, pentane, and other members, several other members you could read from the textbook. So you could practice with all of these members to know what the empirical formula is, what the displayed formula is, what the structural formula is, and what the molecular formula is. All right, so that is how to go about this aspect of formulas. All right, so and I believe it's clear now with our formula. So you could do that for several other members of the alkane series. All right. All right, so next thing we're going to do is to bring in the concept of structural isomers. So we're going to be drawing isomers of some of these compounds. Remember what we said about structural isomers, that they have the same molecular formula but different structural formula. And from the previous video, I said you could have two atoms with, for example, let's look at we could have what we just finished using. We could have butane having the same molecular formula to be C4H10, but the way it is going to be drawn will be different, and it also have a different name. So I'm going to look at it, but before we look at this, I want us to quickly look at naming, because for every isomer that you are able to draw, you're expected to name those isomers. All right, so we'll just quickly look at the rules involved in naming organic compounds, and then we would apply those rules when we start drawing structural isomers, and then we could look at the reactions of alkanes before we round up this particular part of this video. All right, remember that at the end of all of these concepts, we'll be looking at, I'll be solving a video I'll dedicate it to solving past questions. So the essence of this is to first understand the concept and then apply it in solving past questions. So let's look at rules to naming organic compounds. Organic compounds have names because, of course, they have their family, so they have different names that they should be could be used. But the first thing you need to understand about naming is the rules. When you know the rules, you'll be better, you'll be in a better position to apply those rules in naming them. All right, but for the IGCSE chemistry, it's not going to be doing anything really complicated with naming, except maybe A levels, where you would have to advance your understanding of naming. But this is the foundation to naming organic compounds. So the first rule says find the longest carbon chain and choose the correct root name. Okay, so you have to identify the longest carbon chain. That's the first one, and that longest carbon chain is called the parent chain. So the longest carbon chain is the parent chain. All right, so that's the first rule to naming. So you need to count and look at where you have the longest, and that is the parent. So that will be the root name of that compound. Now, the second thing you need to do is to identify and number the parent chain from the end closest to the most significant group. Okay, so basically what I simply do here is when you have the parent chain, you number forward and then you number backward. Okay, we're gonna apply all of these things. So just to take them out first. Now the next thing is identify the substituents and functional groups, and then you place them in the correct position in the name. Okay, so after numbering the chain, that's the longest chain, you need to identify those substituents or the functional groups and pick out their names. We're going to look at some functional groups that you will likely come across. And then the next one is to combine the components into a systemic name. Okay, and then finally, also note that two numbers, that is, the two numbers are representing positions. So remember, we've numbered the chain. So when you have two numbers there, so you separate them using a comma. And then when you have a number and a letter, you can be separated using a dash. So these are the rules for naming organic compounds. We're going to put in the naming together. I'm going to treat naming together with isomers, so structural isomers. So let's go straight to applying these rules into the alkane series and also doing structural isomers. All right, so I'm going to start with butane. I'm going to start with butane. Now, we'll be wondering why we're not starting with propane. Propane, it's a very short chain, so there is really no structural isomers of propane because it's a short chain, and irrespective of the arrangement you might choose to adopt, it's still propane you're drawing. Okay, but for butane, we can have some isomers. We can have, I think, one isomer of butane. That's butane itself. So two isomers of butane itself, and one more isomer. So let's draw butane first. Remember, butane is the general formula is CnH2n plus 2. That's the general formula to generate. And butane is N equals to 4. So we said it's C4H10. So we just draw this. I'll just draw it by the left, so I'll show you the isomer by the right. Okay, so this is butane now. So I'll attach all the hydrogens that are involved.
A lot, and you're like, okay, do you have a private tuition? Don't you have? Do you have? And yes, Ajiro Tech do have a private tuition. So by my right, you can see that we have for the EdExcel and Cambridge IGCSE, and yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have physics, we have biology, we have chemistry, and we have um, you know the flagship, which is ICT, just here and there. We also have business studies. So if you're interested for a private tuition, I think all you have to do is send an email to the sales team at ajirotech@gmail.com, and they would reply to you, talk about your time zone, talk about, and the fee is really quite affordable. Really, it's really quite affordable. It's when you look at it across other tutoring service, I think this is the one that's quite affordable, and you get the very best of service. We also have for the E levels as well, and also for the EdExcel. So we have for the Cambridge E levels and EdExcel E levels. Okay, and we have also across the subject mathematics, which is usually the hot cake when it comes to E level, mathematics and chemistry, and then biology. These are usually one of the ones we have in demand always, all the time. Even physics, for E level. So all you have to do, if you're watching this right now and you are interested for a private tuition, then you can do yourself a solid, okay, and send an email to the sales team at ajiro@gmail.com, and they'll reply to you. And the good news about this is what I've discussed with the sales team is we've tried as much as possible to see how we can subsidize the amount according to countries, so it doesn't really look very, very heavy. Okay, so this is really important. Yes, we do charge in pounds, but again, we try to be as much as possible considerate to your countries, and we don't just skyrocket the price. No, because at the end of the day, we know how it feels, and we really want you to actually get the best of service, and again, be able to afford it from the comfort of your home. So again, Ajiro Tech private tuition is currently ongoing. You can enroll yourself for the IGCSE, and then for the E levels. Again, for the IGCSEs, these are the subjects, and for the E levels, these are also the subjects. So again, what are you waiting for? Just send an email to the system. If you're an IGCSE student preparing for IGCSE, if you're watching this in 2025, watching this in 2026, watching this in 2027, we're currently ongoing, and this is actually a good time for you to actually explore, and then get it tailored to your own needs. So trust me, you don't want to miss out.
Okay, so all right, so this is the butane. This is normal butane, right? Normal butane. And now I want to draw a structural isomer of this. I want to draw a structural isomer of this, and then I'm going to name the isomer by applying the rules for naming. All right, so I'm going to use a different color of ink just to show some difference in the two of them. So now the concept of isomer is, remember we said structural isomers, they have the same molecular formula. So I'm going to draw something that still has 4 carbons and 10 hydrogens, but it's going to be drawn, it's going to have a different structural form. Okay, it's going to be the same molecular formula, same number of atoms, but different ways it's drawn or different spatial arrangements. So now, most times you could say, oh, okay, why don't we swap? So we could move this group. I could move this group, right? And most students will say, let's put it right here. No, you can't put it right here again because it is just like you're swapping the position. It's like you're doing the same thing again. So what you could do is avoid position one. That is, after you circled the group that you want to, adjust, a group you want to rearrange. I'm circling the CH3 group because that's the CH3 group I want to rearrange in this case to draw the isomer. I cannot put it in this position, and I also cannot put it here. I'm not going to put it here because all of these are still position one. Okay, so the best position is to put it right here because that is not position one. The moment you put this on the position one carbon, after you've circled this off, you're still drawing the same thing. All right. So I don't want to draw the same thing. I want to draw something different, and that is why it's an isomer. It's a structural isomer. So I'm going to move the CH3 and I'm going to put it right here. I'm going to replace it with the hydrogen here. And I'm going to move this hydrogen. So they're going to simply swap. I'll swap this with this, and this will come right here. So let's do that now. So it's going to be like this: C, C, C. All right. So I'm moving this off. So I'm putting this at the middle carbon. So it's going to be somewhere here. And I'll put it here. So this is CH3. All right. And then I'm going to attach the hydrogens as usual. So H here, H here, H here. Right. And then the hydrogen I moved from here, I'm going to just put it here. So it's now here. I think I just need to use a red ink. Let me use a red ink to show you the hydrogen I moved off. So you could see what has been done here. So look at the hydrogen I moved. All right. I'm going to go back to the black ink now. All right. So yes. So what I've done is I have swapped a whole group. This is the CH3 group. I put it on this on a different carbon, and I moved the hydrogen. This is the hydrogen I moved to this position. All right, so that is what structural isomers is all about. So I've replaced a whole group here, put it here, and I moved the hydrogen there. All right, so what I've simply done is, if you look at the two structures, all right, let's look at the two structures. In the first one, that's the first structure here, we had a straight chain of 4 carbon atoms. All right, but in the second structure, we have just a straight chain of 3 carbon atoms. The number of carbons are the same. There are still 4 carbons and 10 hydrogens on both diagrams. You could count it. We still have 4 carbons and 10 hydrogens on both diagrams. All right, so what this represents is simply a structural isomer. So this second structure is a structural isomer of this. Now, before we name, let's look at how to identify substituents quickly, and then we'll come back to name this. So some of the substituents you're going to see in naming organic compounds is, let's see some of them. You're going to have some of the halogens. All right, so if you have a chloro group, if you have chlorine, so it's called chloro. If you have bromine, it's called bromo. Okay, if you have the iodine group, it's called the iodo. All right, if you have a CH3, remember this is an alkyl group. So the alkyl groups, alkyl, I mentioned that in the previous video, that the general formula is CnH2n plus 1. All right, so it's simply an alkane group short of a hydrogen. So if we have methane as the first member of alkane, so the first member of the alkyl is simply methyl. So you should know that when you're generating the members of the alkyl, they are short of one hydrogen and they have the YL to end it. So we have methyl, ethyl, propyl, butyl, like that. All right, so this is another group that you can likely come across when you are naming. All right, so these are some of the substituents that you'd always see. All right, now that we've seen this substituent, let's now go back to our naming. Let's go back to naming now. So remember, these are substituents that the rule says you should identify. So let's go back. Let's go back to the rule for naming. So I'll just project the rules and then you follow it gradually. So the first rule says find the longest carbon chain and choose the correct root name. All right, so I'll just go back to this. What would be the longest in this case? So the longest is, that is 1, 2, 3. This is basically the longest. All right, this is the longest. Okay, so the longest is this. If whether I want to count from down as well, it's still going to be 3. So whether you count forward or you're coming from all the way down here to the left side, or all the way down from the all the way down to the right hand side, it's still going to be a maximum of 3 carbon atoms. All right, so I've numbered them. I'm picking this direction to represent my longest chain. So the rule says you should number, identify the longest chain, and identify that, and I've numbered it. So the rule also says when you number, also number backwards. So I've numbered forward, I'm also going to number backwards. So 1, 2, 3. So if the longest chain is 3 carbon atoms with single bonds, I could boldly say that the parent is called, my parent's chain is now propane, because propane fits into that description. 3 carbon atoms with all single bonds, that's propane. Okay, so the name of the parent is propane. Now the next rule says, after identifying the parent, it says name the substituents and the functional groups. So what are the functional groups in the structure? All right, so the functional groups are those groups apart from hydrogen. That's what you simply, that's a better way to look at it. So those groups apart from hydrogen. Now, why do I say apart from hydrogen? Because when we talk about functional groups, I said functional groups are atoms or group of atoms that affect the chemical properties. All right, they affect the chemical properties. So this hydrogen is part of the structure, the initial structure of butane. So it's more like it's a family already there, it's there. So what is changing here is this. So this is basically a new entity that has been introduced to the chain, basically. So this is what is going to affect the property now. Okay, so this is the functional group, but this is the substituent. And when you have a substituent like this, so the substituent is CH3, and what is the name of the substituent? We already said that when you have a CH3 group, it's an alkyl member, and then it's called methyl. So the name of our substituent is methyl. All right, the name of our substituent is methyl. All right, so we've applied the rule now. We've gotten the parent, we've gotten the substituent. So let's go back. It says combine the components into a systemic name. All right, it says two numbers are separated using commas, while a number and letter can be separated using a dash. So we're going to name the substituent first before we attach the parent. All right, so when naming the substituent, we also have to put the position of the substituent. Okay, so first step is to pick out they said you pick out the position of the substituent. So what's the position of the substituent looking at this diagram? If this is the substituent, it's attached to position 2. So it's attached to carbon 2 going forward, and it's also attached to carbon 2 going backward. Now, for the fact that it's attached to the same number, same position of carbon forward and backward makes it very easy. So it's position 2 in both directions. But if it were position 2 and position 3, maybe going forward it was position 2, going backward it was position 3. You give priority to the lowest number. That means you give priority to 2 and not 3. But in this case, we have 2, so we stick to 2. So what will be the name of this compound now? So I'll pick the position of the substituent first. So it's going to be 2. And then I want to put in the substituent name, which is methyl. So I said a number and a letter. We separate them using a dash. So 2 dash methyl. And then I now put the parent. So what's the name of the parent? Propane. So this is the name of this structure now. It's 2-methyl propane. Okay, so that's how to apply the rule. We're going to do one more example to apply this rule. So this 2-methyl propane is simply an isomer of butane. All right, the same number of carbon, the same number of carbon atoms, the same number of hydrogen atoms, but different representation. Okay, so this 2-methyl propane is an isomer of butane. All right, so I'm going to pick another example now, and I'm going to show you again how to draw these the isomers. All right, so let's go to a member a bit long, a member that is longer, kind of, with more number of carbon atoms, basically. So I want to use hexane this time. Hexane. All right, so I'm going to we're going to look at isomers, structural isomers of hexane, and then we'll also look at how to name those isomers. All right, because we're doing two things. We name and then we draw the structural isomers. So hexane is N equals to 6. So CnH2n plus 2. So that's basically N equals to 6. So if N equals to 6, so it's going to be C6H2 into bracket 6 plus 2. All right. So it's going to be C6H12 plus 2. All right. So the formula will become C6H14. So this is the molecular formula of molecular formula of hexane. All right, so if this is the molecular formula of hexane, we'll just try and get, derive some isomers of this, and then we'll kind of end this video, and then next video we'll look at reactions of the alkanes.
A lot, and you're like, okay, do you have a private tuition? Don't you have? Do you have? And yes, Ajiro Tech do have a private tuition. So by my right, you can see that we have for the Edexcel and Cambridge IGCSE, and yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have physics, we have biology, we have chemistry, and we have um, the flagship, which is ICT, just here and there. We also have business studies. So if you're interested for a private tuition, I think all you have to do is send an email to the sales team at ajirotech@gmail.com, and they would reply to you, talk about your time zone, talk about, and the fee is really quite affordable. Really, it's really quite affordable. It's when you look at it across other tutoring service, I think this is the one that's quite affordable, and you get the very best of service. We also have for the E levels as well, and also for the Edexcel. So we have for the Cambridge E levels and Edexcel E levels. Okay, and we have also across the subject mathematics, which is usually the hot cake when it comes to E level, mathematics and chemistry, and then biology. These are usually one of the ones we have in demand always, all the time. Even physics, for E level. So all you have to do, if you're watching this right now and you are interested for a private tuition, then you can do yourself a solid, okay, and send an email to the sales team at ajiro@gmail.com, and they'll reply to you. And the good news about this is, what I've discussed with the sales team is, we've tried as much as possible to see how we can subsidize the amount according to countries, so it doesn't really look very, very heavy. Okay, so this is really important. Yes, we do charge in pounds, but again, we try to be as much as possible considerate to your countries, and we don't just skyrocket the price. No, because at the end of the day, we know how it feels, and we really want you to actually get the best of service, and again, be able to afford it from the comfort of your home. So again, Ajiro Tech private tuition is currently ongoing. You can enroll yourself for the IGCSE, and then for the E levels. Again, for the IGCSEs, these are the subjects, and for the E levels, these are also the subjects. So again, what are you waiting for? Just send an email to the sales team. If you're an IGCSE student preparing for IGCSE, if you're watching this in 2024, 5, watching this in 2026, watching this in 2027, we're currently ongoing, and this is actually a good time for you to actually explore, and then get it tailored to your own needs. So trust me, you don't want to miss out.
All right, so C6H14 is the molecular formula. And remember what structural isomers are. They should have the same molecular formula, meaning they should have the same number of carbon and hydrogen atoms, but different arrangements, that is different structural formula. So I'm going to draw the normal hexane here. So 1, 2, 3, 4, 5, 6. Okay, so 6 carbon atoms. Remember, it's an alkane, so you should have only single bonds. Right. And then I'm going to attach 14 hydrogens. So remember what we do. Carbon can only have 4 atoms attached to it because it has a valency of 4. So 1, 2, 3, and this is the 4th bond. So we're not going to attach any other thing to this. So we just complete this. Right. So this is basically hexane now. All right. Now we have hexane. Okay, so the next thing is we want to start drawing the structural isomers of hexane. So I'll just simply draw as n hexane. This is normal hexane. All right, so just like I said earlier, the idea is to pick out a group and move it to a different position apart from position 1. So let's assume this time I want to move. So I'm going to circle the group I want to swap. So I'm going to swap this old CH3 group. I want to swap it. So I've circled it. Remember, I cannot put it here. This is wrong, and I cannot put it here. All right, so those are the 2 positions that are off, because if I put it there, I'm simply drawing the same thing. All right, I don't want to draw the same thing. So the positions I can likely use are these 3 carbon positions. So I could use here, I could use here, and I could use here. So I'm going to swap. So let's basically swap this. I'm going to move one of the hydrogens here, whether the one at the top or the one below, it doesn't make any difference. All right, I'm going to swap this. So this, we're going to swap. Okay, CH3 will go, H is going to go here, CH3 is going to come here. All right, so let's draw the new isomer. Let's draw now. So that means I'm not going to draw this one again. I'm just going to draw 1, 2, 3, 4, 5. So I'm going to draw 5 carbon atoms now. So 1, 2, 3, 4, 5. All right, and then I'll draw what I swapped. So I moved this CH3 to this position. All right, so this is the position where I moved the CH3 to. Okay, so I moved the CH3 to that position. Okay, and then I move the hydrogen to occupy all of this position. That's the hydrogen is occupying every position here. So this is the hydrogen. I'm just going to represent it with a different marker, a different color rather. So I'll just put the purple to show you the hydrogen that moves to that position. All right, so hydrogen is simply occupying this position. Oh, I think it doesn't make any difference. The purple is kind of the same. So let me use yellow. Okay. All right. So purple is yellow. So this is the hydrogen I swapped. Okay. So let's go back to the black now. All right. So hydrogen has taken that position. Then I'll put off these 2 hydrogens here. So H, H. All right. And then hydrogens all through. So H, 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 and H. All right, so this is the new structure. Now, just look at it. The first one had a long chain of 6 carbon atoms, but this one has a long chain of about 5. 1, 2, 3, 4, 5. So that's how to draw isomers. All right, so it's majorly you're going to have the same number of carbons, and you're also going to have the same number of hydrogens. All right, I forgot to put this, so sorry, it should be a hydrogen here rather to complete the structure. So you could count it. You have the same number of carbons and the same number of hydrogens. So when you're drawing your structural isomers, ensure that the same number of carbons that are in the parent, the first structure, are also there. The same number of hydrogens are equally there. So we want to name this. All right. So naming this now, I'm going to simply pick the first rule. Remember what the rule says. Find the longest chain. Right. So my longest chain here, I'll just number. I'll number with let's use a green. Let's use green this time. So I'm going to number. So it's going to be 1, 2, 3, 4, 5. So the straight chain, the longest is simply 5. And then whether I choose to go, remember, I could choose to come all the way from here. So it's still 1, 2, 3, 4, 5. Whatever direction, you'd observe that the longest is 5. All right. So I'm not going to number that way anyway. I just show that. So you see that just like we mentioned, one of the unique natures of carbon is to have chains, okay, chains, long chains, branch chains, and the like. So this is an example of a branch chain anyway. So, all right, so I'm going to number backward as the rule of equaries reminds us to always do. So I've numbered forward, I'm going to number it backward. So 1, 2, 3, 4, and 5. All right, so now that I've numbered forward and backward, let's name the parent. So what do you think the parent is? The parent is the longest chain there, so which is 5. And five carbon atoms with single bonds. So 5 carbon atoms with single bonds is an alkane, and it's called pentane. Pentane. All right, pentane. Now, after identifying the parents, what are the substituents? So substituent, like I mentioned, like we did in the previous example, it has to be a group different from hydrogen. So if you look at it, you see that this is the only group that is different from hydrogen in this case. Okay, so and that group is a substituent. So our substituent is methyl again. So we have our substituent to still be methyl. Substituent to still be methyl. Okay, so it's time to name. We know the parent, we know the substituent. So the next thing is to look at the position of the substituent and then name. So we remember the rule. The rule says, what's the position of the substituent? Now, if you go forward, the position is position 2. That is, if we are counting using the green numbering up here, is 2. But if we are counting using the red or the red numbering below, that's 4. And I mentioned earlier that when you were numbering and you have one to be higher than the other, you give priority to the lower number. So instead of using 4, I'm going to pick 2 because 2 is lower. So it's going to be 2 hyphen. What's the name of the substituent? Methyl. And then what's the name of the parent? Pentane. So this is one of the isomers of hexane. All right, so this is one of the isomers of hexane, 2-methyl pentane. All right, so that is basically it. I'm going to do one more isomer of this just to show you different dimensions that this can take. So I'm going to simply shorten this. I want to shorten this to 4 carbon chains. This is 5, so I'm going to shorten it to 4. Okay, so let's shorten it to 4 this time. So basically, what I'm going to do is we're going to swap again, like I mentioned. So we're going to have 4 carbons. 1, 2, 3, 4. So I want to reduce it to 4. Remember the original number of carbon atoms we are dealing with is 6. So I'm going to reduce it to 4. I'm going to put 2 CH3s here. So CH3, CH3 to make everything 6. And then hydrogen, 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 and hydrogen. All right, so look at this. Number of carbons is the same thing with the hexane we drew earlier. So number of carbons is 6. So how many carbons do we have here? 1, 2, 3, 4, 5, 6. Still 6. Number of hydrogens is 14. And number of hydrogens here is equally 14. So it's the same thing. All right, I just choose to draw it in a different way, like extension. So I'm going to do numbering again. So longest chain here is going to be 1, 2, 3, 4. So however you want to adopt it, the number backwards as well. It's going to be same thing. It's going to be the same thing. 1, 2, 3, 4. All right. So our parent is going to be the longest. So 4 carbon atoms. All of them are um, single bonds. So it's basically butane. So the butane again. And then we'll look at the substituent. So substituent, we have 2 substituents this time. So our substituents, so we have 2 substituents. We have this and we have this. Okay, so if we go forward, they have position 2, 3. If we come backward, they have position 2, 3. So we just know that there are 2 methyls there. So there are 2 methyls here. So it's going to be a dimethyl. So we have 2 methyls. That means dimethyls. That is position 2 and 3 for both of them. Okay, so now that we know the substituents and we know the parents, let's name now. So we name, whether I want to go forward or backward, is the same numbering. Okay, so we say 2, comma. Remember, 2 numbers are separated using a comma. So we want to represent the two methyls that are there. So the first one is position 2, the second one is position 3. All right, so 2, 3. Now, what does this position represent? It represents dimethyls. So 2, 3 dimethyl. All right, and then we'll now name the parent, which is butane. Okay, so this is another way of naming organic compounds based on the structure that we have. So this is simply applying the rules of naming as well. See, if there are two groups, same groups, you use the comma and then you use the die. If there were three, it's going to be 2, 3, whatever another number, trimethyl. All right, so that is naming. We will keep on naming. Maybe we'll do a special video where we have to name so many compounds, but this is just the basic of naming organic compounds as far as IGCSE chemistry is concerned. All right, so and if you understand this, you understand the rules and you understand the substituent, then you are good to go with naming this. So this is another structural isomer of hexane. So we could have more and more isomers. There are many other isomers you could try. So I'll leave you to try more, practice all that we have said in this video. Okay, and drop your comments in the comment section as you watch the video. Is there any clarity that you need? All right, so this is where we're going to end this part of the video. In the next video, we'll go straight to reactions of alkanes. All right, and we'll look at the same video. I want to look at the same concept. We look at alkanes, draw structures for alkanes, and then we'll look at reactions of alkanes, and then we go straight to some topical papers. All right, so thank you for watching.